Good morning, learners. My name is Mr. Pochilola. Once again, we meet in this hour for a lesson in AS Physics. AS Physics, so I decided to make this video as an introduction to AS Physics for my current AS Physics students. So Unit 1 is a topic called the physical quantities and the units. Students doing other curricula can also benefit from the same lesson, but primarily this lesson is prepared for my current AS physics students and students from elsewhere. They can also benefit from the same. So in the course of the lesson, you may come across concepts that are hard to understand. I'll be glad to address any concerns based on your misunderstanding. All you can do is just make comment in the comment section below, indicating that you need clarification on something that I did not make clear. So once again, welcome. If it's the first time you have visited this channel, I would kindly request you to consider subscribing to the channel so that every time I post a new video, you are the first to be notified. You may also consider to invite your friends, inform your friends that it is possible to learn on this channel at no cost. Invite as many of your friends as possible. All right, so this is just an introduction to the unit, which is called physical quantities and the units. So, what are the learning outcomes for this topic? When you have fully understood or learned or completed this unit, I expect you to be able to do the following. So we are saying by the end of this topic, you should be able to understand that all physical quantities consist of numerical magnitude and a unit. Right, so whatever you measure in the lab has two parts, right? So any quantity that you measure in the lab, whether you are measuring length, mass, thickness, time, all right, when you're writing it down, you make sure that your quantity has two parts, namely, it has a number showing how big it is, and it also has a unit which is attached to it. So we are saying you should be able to understand it all the time that all physical quantities consist of numerical magnitude. The word magnitude simply means size, how big something is. And it is a number, and attached to the number there must be a unit. You should also be able to make a reasonable estimate of physical quantities which are included within this AS syllabus. All right, so you'll be required to make a reasonable estimates. For example, you can estimate the height of an average adult human being, or you can estimate the mass of an apple, or mass of a new pencil, mass of a coin, length of a book, a physics book. All right, so all these to be made within a reasonable limits. Okay. You also be required to recall the following SI-based quantities and their units. All right. So you are recording from where? You are recording from your IGCSE syllabus. Okay. So in your IGCSE syllabus, you have or you met quantities such as mass, which is measured in kilograms, length in meters, time in seconds, current in ampere, and the temperature in Kelvins. So within your AS syllabus, you'll be required to recall these. Able to express derived units as products of quotients. You should be able to express derived units as products or quotients of the SI base units and use the derived units for quantities which are listed in this syllabus as appropriate. Okay. You should not worry about what derived units are. We are going to look at what these are and then be able to express them as either products or quotients of SI base units. But those base units are the ones that are listed in this AH syllabus. You should be able to use SI base units to check the homogeneity of physical quantities. We are going to define homogeneity within the topic, and you shouldn't worry at the moment what homogeneity is. We are going to break it down for you. And then we are going to, you'll be required also to recall and use the following prefixes and their symbols to indicate decimal multiples or submultiples of both base and derived units. Namely, we are going to look at the pico, nano, micro, mil, cent, dec, kilo, mega, giga, and tera. Right. So you are going to be required to recall, should be able to recall and use these prefixes and their symbols to indicate decimal submultiples or multiples of both base and derived units. You should be able to understand and explain the effects of systematic errors, including zero errors and random errors in a measurement. We say that no measurement is 100% perfect. Measurements are associated with errors or what we call uncertainties. All right, so you are going to be required to understand and explain the effects of systematic errors, including zero errors and random errors in measurements. All right, so don't worry about what random errors are, systematic errors. They're going to get clear as we go along in this topic. You should be able to understand the distinction or the difference between precision and the accuracy, and of course, also solve problems involving precision and accuracy. All right. You should be able to assess the uncertainty in a derived quantity by simple addition of absolute or percentage uncertainties. Okay, we'll say what precision is, rather we'll say what uncertainty is, and relate this to solving problems. All right. So later, you should be able to understand the difference between scalar and vector quantities and give examples of scalar and vector quantities included in this syllabus. There are some vectors that may not be part of the syllabus. Maybe they're in A2, all right? But as long as we are looking at those which are included in this syllabus, you should be able to tell the difference and between vectors and scale quantities and give examples. You'll be required also to add and subtract coplanar vectors, that's vectors in the same plane. Okay, so we're going to look at how we add and how we subtract vectors. And then we are going to look at how you can represent a vector as two perpendicular components. That's what we call resolving vectors into their components. All right. So these are some of the objectives that we are going to achieve in this topic. All right. So what is the quantity, physical quantity? In physics, when we say something is a physical quantity, what does it mean? You might look, or you may have looked at the meaning of a physical quantity before, but for the convenience of this syllabus, the AS syllabus, we are going to define a physical quantity in the following manner. All right. We shall define a physical quantity as a feature. Physical quantity is basically a feature of something which can be measured. In other words, a physical quantity is anything that you can measure in the lab. Examples of physical quantities are many, but here we can look at length, mass, and time as examples of physical quantities. You would be required to measure the length of a wire, for example. So length of a wire is a physical quantity. You can be asked to measure, say, mass of a coin. So mass of a coin is a physical quantity. You may be required to measure the time interval for a certain event. Therefore, time is also a physical quantity. So anything, think of anything that can be measured. Anything that can be measured in the lab, the physics lab, is a physical quantity. All right? There are certain things that you don't need to measure. For example, you cannot measure attitude or love. How much you love someone cannot be quantified. So you can't measure love in terms of, in the physics lab, you cannot do that. You cannot measure things like hope, hoping for something. You cannot measure that. Therefore, those hope, love, attitude, mentality are not physical quantities because these cannot be practically measured in a physical lab. All right. So features such as length, mass, time, temperature, you can think of others like volume, density, speed. All these are physical quantities because they can be measured. They can be measured in the lab. You can measure them and you can quantify them using appropriate instruments. So every physical quantity has two parts. Remember the first objective, the first learning outcome says that we should state that a physical quantity has numerical value and a unit. Whatever you measure in the lab has two parts. Numerical, it has a numerical value, a number, and a unit attached to it. For example, the length of this page is 27.5 centimeters. All right. So the 27.5 is a numerical value. The 27.5 is a numerical value, while the centimeter is a unit. So we are saying every physical quantity has a numerical value. For example, the length of a page is quoted as 27.5. So the 27.5 is a numerical value. It's the magnitude. And the centimeter is the unit. The mass of an apple is 450 grams. The 450 is a numerical value, while the gram is a unit. The time to run a 100-meter distance is 12 seconds. So the 100-meter, 100 is numerical value, while the meter is a unit. Similarly, for time taken, the 12 is a value, the s or the second is a unit. So every physical quantity which you measure in the lab must have these two parts. In other words, without unit, such a quantity is as good as useless. So a quantity that has no unit does not mean anything at all. It's as good as useless. So if someone says they are able to run a distance of 1,500 in 200 seconds, they could be very fast or very slow, depending on whether the measurement of distance is in meters or centimeters. So there is need to attach a unit at the end of the distance covered. Otherwise, it will be confusing to the reader. If your unit is not specified, well, the reader would be wondering to say what were the units. So units must always be included when quoting a measurement. So you need to be careful. You need to take care. It is very important. It is vital to give the unit of measurement whenever a quantity is measured or written down. So don't just state a measurement without units. Otherwise, it will be misleading and it will be pointless. It's pointless to present a quantity without units because it will not have a meaning to the reader. All right. So once again, like I said, this is just introduction to the topic called physical quantity and the units. Next time we meet, we are going to look at other aspects of the topic physical quantity and units. In case, once again, you have questions or you are lost somewhere, don't hesitate to say your concern, to comment. Just leave a comment in the comment section and indicate that you need clarification, and we are going to be able to come back to you and rectify the misunderstanding. My name, once again, is Mr. Paul Chilola. Once again, if you are joining to the channel so that every time a new lesson is uploaded, you are probably the first one to be notified. So consider liking, subscribing, and then hit the notification bell so that you don't miss on any videos that are shared. For now, let's meet in the next lesson on the same topic called physical quantities. My name, once again, is Mr. Chilola, your teacher on this forum. And there are times when you'll be joined by other teachers for chemistry, AS, chemistry, biology, and mathematics. Bye-bye for now.